do you remember from grade 11 pre-cal how to solve this radical algebraically? Yeah, you square both sides. So x plus 2 equals 3. We're going to square both sides because a square undoes a square root, right? So then we get x plus 2 equals 9. Move the 2 over, we get x equals 7. And the most important thing when we were doing these types is because we were adding in that squaring both sides, sometimes we get thrown an extraneous root. So we always should check our original. So sub x equals 7 into the original. Does it work? Yes, it does. Okay, so now I'm going to show you what this actually looks like graphically. So we're going to solve this by finding the point of intersection. So now we kind of mentioned this before, I think, but if you don't, does anybody know how to graph this equation? If I want to find the point of intersection of the two, what would I have to graph? And something like this is something you should, if you have the graphing calculator will give you 7 as your answer if you know how to actually graph it, right? Did you realize that? So what do we graph? To find the point of intersection, we graph this side and we graph this side. So this will be my y1 and this will be my y2. We're going to graph this one by hand, but normally we could do this on a graphing calculator. So if I were to graph y1 equals x plus the square root of x plus 2, what is that? It's a square root function that got shifted left 2. So then my 0, 0 is going to be at minus 2. My 1, 1 will be there. And then 4, 2, right? 1, 2, 3, 4, 2. Yes? And let's go one more and do 9, 3. So 5, 6, 7, 8, 9, 3. So there is my square root function. So that's a great review for the test. Well, that's why I'm saying it's a good review at the end, right? So you have to be able to graph a base square root function and any transformations of it, okay? So this would be considered a transformation of a square root function. And then if I wanted to graph y2 equals 3, how would I graph that? That would be the constant line going through that. Does everybody see? So where does it intersect? Yeah. It's intersecting at 7, 3, but I don't care about the y. The original question did not have a y in it, so my solution is the x coordinate of the intersection. So what are they going to ask you on the exam? They're going to ask you is if you were to solve this graphically, or they might say, someone solved this graphically, what is the solution? What are you supposed to be looking for? You have to understand what you're looking for here. So this would be on the non-calculator part, right? So now we're going to graph using the x-intercepts. So we're going to graph y equals, we're going to shove this 3 over to the other side. Do you see that? And we're going to get the square root of x plus 2 minus 3 equals 0, and we're going to graph this part of our equation. Does everybody see what I did? I moved the 3 over to the left side. I have the other side equal to 0. So does everybody understand if y equals 0 on the other side, what am I looking for when I graph it? The x-intercepts this time. So how do I graph this square root function? 2 to the left, 3 down. So 2 to the left, 3 down. 1, 2, 3. Then we do our base 0, 0, 1, 1, 2, 4, 2. So it's 2, 4, 2, and then 3, 9. So 4, 5, 6, 7, 8, 9, 3. There you go. Yeah. So again, this is my x-intercept. X equals 7, right? Does everybody see in all 3 examples, my solution is x equals 7. You're just looking at it different ways. So your whole thing is you need to understand what you're supposed to be looking for, because they'll ask you, oh, well, you know, Joey tried to solve this graphically, but he didn't know where to look for the solution, right? And so you need to actually say, and you can't just say it's the intersection of the two, the line and the curve. You have to say it's the x coordinate for the B1 of the intersection. In C, you have to say it's the x-intercept of the curve, right? Okay? Okay, so we're going to do this one. Solve the radical two ways. So we're going to do this algebraically. So, do you remember how to do one of these algebraically? Yes, move 3 over. So x plus 3 equals x, oh sorry, square root of x plus 3 equals x plus 3. Yes? Then what? Then we square both sides. Now watch, when I square the right side, what do I have to remember? You have to FOIL. So this is x squared plus 6x plus 9. Then what do I do? Move everything over. So I get x squared plus 5x plus 6, yes? Then what do I do? Factor. Don't drop your equals 0. Factor. So what do I get there? Plus 3 plus 2. So that means x equals -3, -2. What do I have to remember to do when I square both sides? I need to, make sure you go into the original. So -3 goes in, I get the square root of 0, subtract 3 is -3, and -3 equals 3. So that one checked. What about -2? -2 goes in there, right? And -2 plus 3 is 1, square root of 1 is 1, 1 minus 3 is -2, and that equals -2. So they both checked. Interesting. A lot of times when we get two answers, we have to reject one of them. Okay, how are we going to graph this then? You don't know? Well, we can graph it the way it's written. I don't think anybody knows how to graph this with a graphing calculator and find the x-intercepts. I think we need to do, does everyone understand? Graph two things and find the intersection, because that's the only thing we know how to do. So sometimes the x-intercepts are out of the question, because unless we have a graphing calculator, and then we can solve it, right? So we could graph it the way it is, or I can move the 3 over. What do you want to do? You want the 3 over? So we're going to graph x plus 3 equals the square root of that. So this is going to be my y1, and this is going to be my y2. Yes? So how do we graph y1? Shift it over 3, right? 0, 0, 1, 1, 4, 2. 1, 2, 1, 2, 3, 4, 2. I'm going to go one more and do 5, 6, 7, 8, 9, 3. And you know from grade 10, when you've found systems of equations graphically, unless you graphed it very precisely and it intersect at a whole number point, it was very difficult to actually solve graphically, yeah? Okay, so how do I graph y2 equals x plus 3? A point on 3, up 1 over 1. So I'm going to continue it down. Does everybody see the intersection there? I'll use a different color pen. The intersection is 2 different points. There's a point at -3, 0, and a point at -2, 1. So what am I supposed to take from that? I'm only taking the x coordinate, right? So x equals -3, -2. So that shows graphically why there's two solutions, because it's intersecting in two spots. Make sense? Okay. Do you remember how to graph this? The square root of 4 minus x squared. So we need to, And this is on the test, so this is a good review, right? So we need to be able to graph the parabola. What's the parabola? It's a parabola that's upside down, shifted up 4, right? And like that. And then what happens after I do that? I'm going to gray it out because this is not what I want. This is only helping us get the square root function, right? Oh, sorry, I went directly to graphing. This is my y1, this is my y2. So in order to graph f of x equals the square root of 4 minus x squared, I'm graphing the inside first. That's that gray thing. You have to be able to do this for the test, right? And what do? We square root all the y values. So -2 stays as -2, +2. The 4 becomes a height of 2. Wherever the height of 1 is, it's there. And then it goes like a little speed bump, we call it. 4 minus x squared. Okay, so my other one is y equals 2. Does everybody see it's going across like that? So what's my intersection there? 0, 2. So what's my solution? What's my solution? X equals 0. I wanted to do the graph first because if we already know what we're looking for on the graph, it's pretty easy, right? Was it harder to know what the solution was this time? Or was it just harder to graph it? Okay, so let's graph, or let's algebraically solve it. So the square root of 4 minus x squared equals 2. What do we do here? Square both sides. So 4 minus x squared equals 4. Move the 4 over and the x over, we get 0 equals x squared, so x equals 0. Yes? We good? Okay. Again, I want to graph this first so we know what we're looking for and not getting swayed by our answer. So it's already actually telling us we have no solution. So we're going to graph this just for practice. And this, okay? So do you know how to graph square root of x minus 3 plus 4? It's right 3, up 4. 1, 2, 3, 4. And then you have a 1, 1, 4, 2, 1, 2, 3, 1, 2, 3, 4, 2. There. Yes? And then how do we graph y equals 2? Huh? It's a constant line going like that. So does everybody see why there's no solution? No, it's not. It doesn't have to do with the fact that it doesn't have an x-intercept. There's no intersection. Yes. No point of intersection. We learned this in grade 10, right? If there's no point of intersection, there's no solution, right? Yes? What happens if they were the exact same line from grade 10? It was infinitely many solutions, right? Okay, algebraically, we have the square root of x minus 3 plus 4 equals 2. Move the 4 over, I get the square root of x minus 3 equals -2. In grade 11, you should have recognized that you can never have a square root equal to a negative number, but some people didn't. They're just so methodical, and they got, oh, now I need to square both sides, and they end up getting an answer, right? But at this point, you should be saying no solution. Does everyone understand that? But say you forgot and you squared both sides, you get x minus 3 equals 4, then you get x equals 1, but then when you sub it in, do you see you get no solution out of it? Either way, here no solution or here no solution, either way there's no solution, right? Yes?